Now it's my pleasure to introduce our next speaker. Malini Suchak comes to us from the cognitive lab, Franz de Waal's cognitive lab at Emory University. Malini Suchak is in the final stages of her graduate studies there and has spent much of her graduate studies, all of her graduate studies, focused on non-human primates, but her interest is now extending to carnivores and is going to be sharing thoughts about that. Malini Suchak.
Thank you, and thank you so much for the opportunity to be here and share some of this work. So the title of my talk is Cat Social Cognition, and I'm sure that some of you may have seen this, and the word social might have jumped out at you, and this kind of look might have crossed your face. I actually had fellow animal cognition people that I work with, one of them nearly choked on his coffee laughing when he heard that that was the title of my talk, because as we know, most adult cats are solitary. But what I hope I'm going to be able to demonstrate today is that as predators, they require specific cognitive abilities, and some of these are rooted in social cognition. And I'm actually so glad that I'm going now, right after Dr. Mendel, because he just sort of illustrated the point that for them to kill their prey is actually a very, fairly precise process. And it's not necessarily a particularly easy process. So I think that this requires, he sort of went over the physical side of killing, and I'm going to talk a little bit more about the mental side of what makes them the predators that they are. So how do cats learn how to hunt? If they're solitary as adults, they have to learn during development, and individual learning is very costly. Individual learning would be from, say, trial and error, and if you're trying to catch your prey, which you need to survive for food, errors are very costly. And so you need a shortcut in learning to help you learn faster. And this is often the case across a lot of species where we see observational or social learning. You expect to see this when trial and error just won't cut it, and you need a shortcut. And I would argue that it is so critical for survival that you can actually look one step further from simply observing what somebody else does and copying that to active teaching. Now, teaching is a step farther. So during observational learning, the individual you're observing is just doing the action, and you sort of learn, just from watching what they're doing. They're not necessarily responsible for your learning. Teaching requires a little bit more. The teacher modifies their behavior in the presence of a naive observer. The teacher usually incurs a cost, or certainly doesn't benefit. So by modifying their behavior, they may be less efficient. They may lose prey. We're going to talk a lot about some of these examples. And the third criteria is that the observer learns more quickly or efficiently than they would by themselves. So you need to show a benefit for the observer. And evidence for teaching in non-human animals is very, very rare. So there are 3 cases where they've looked for these criteria and they've actually found them. All 3 are in the context of foraging, and you actually have meerkats, pied flycatchers, and interestingly, tandem running ants. This is very diverse, right? These are not particularly closely related species. And it seems that, the big argument would be it's very rare, it's certainly not arising from a common ancestor in this case. But then you take the felids. These are all species where we have evidence for at least 2 out of the 3 criterion, if not 3. And I would argue that the reason why we don't necessarily see them all is not because it's not there, but because a lot of these species are solitary forest dwellers, and it's hard to get this kind of data. In felids, we see a lot of evidence for teaching. So all of the species listed, we see that the teacher modifies their behavior in the presence of a naive observer. The teacher is usually the mother, the naive observer usually offspring. The teacher incurs a cost. Feeding efficiency goes way down when mothers are in the process of teaching their offspring how to hunt. And then the third one is the one that's harder to find because, of course, you need to find offspring that do not have parents around to teach, and that's a little bit more difficult to come across in the wild. But I want to go through a couple examples where we actually do have controlled studies with data. So to start with domestic cats, Carol ran a very detailed study looking at how the mother modifies her behavior in relation to prey and how kittens learn about this. And so in the beginning, it's simply a matter of bringing back dead prey and the mother eats it. And the thought is that through this, kittens learn what animals are prey and what are not. And then about the 5th week, so just 1 week later, the mother brings back dead prey, but her own eating decreases. And the kittens start to eat the prey, but they also start to bat the prey around. So they start to play with the prey, they start to interact with the prey, even though it's already dead at this point. And then it gets really interesting around the 6th to 7th week. The mother brings back live prey now at various stages of sort of incapacitating it, and will go retrieve the prey if it escapes, and she vocalizes a lot, and she's not so much interacting with it herself in terms of biting it or approaching it to kill it herself at this point. And so here's a video. So this is really where they learn how to handle the prey. And in this case, the vole escaped. Theoretically, at this point in time, if the prey starts to escape, the mother should actually be going to retrieve it and bring it back and give the kittens a second chance. And so the kittens are really beginning to interact with the prey. And then by the 8th week, so relatively rapidly, it's every cat for him or herself. And the mother stops waiting for the kittens to interact with the prey and just goes for the prey herself. She resumes eating it directly, and the kittens begin to capture their own prey at this point in time. So this was a relatively detailed study, and as the video alluded, kittens that don't have this kind of training don't develop the proper skills. Interestingly, Carol was actually able to take this out into the field with cheetahs who live in a nice open grassland, and so you can easily watch sort of the details of their behavior and their development here. Instead of being on a scale of weeks, it was on a scale of months. It started at about 1.5 months and went up to 10 months of age before they were starting to kill prey, and really it's up through the first year and a half when they really start to actually be able to kill the prey themselves. What was interesting was, in addition to modifying, whether the prey was alive or dead, the mother actually modified the type of prey. So, when cubs were less skilled, they got hares or things that were easier to catch. When they became more skilled, they got neonate gazelles. And they were very high cost for the mother. So her feeding efficiency decreased a lot. Cubs only killed 46% of the hares, which means the majority of the time the food actually got away. And this is much, much lower compared to what the mother could do just hunting on her own. So there was definitely a cost for the mother here. So in a field where we have a very hard time demonstrating positive evidence in animal cognition, we actually find a lot of evidence for hunting. And we find evidence for all 3 criteria in at least some species. And it seems to be really widespread through the family, but that family seems to be unique among all the other species in terms of the prevalence of teaching. One of the things you might have noticed is that lions were really absent from that discussion. And the only piece of the puzzle that lions sort of fit into here is that the mothers bring back dead prey for their cubs. So it could be a social learning for the type of prey, but a very simple explanation for that is if they're weaned, they're bringing back food for their young. And it's not actually part of the learning process of what's the appropriate prey or anything like that. And there's a suggestion that there may actually be a trade-off between teaching and pack hunting. Since lions are not solitary as adults, it's not as critical that they acquire these skills before they go off on their own. And they can acquire the skills of pack hunting in the group with the rest of the group as they age. And there's some evidence that they kind of gradually integrate into the hunting patterns. And so for the second part of this, I'm going to talk a little bit about the cooperative hunting patterns, which, as has already been mentioned, are the vast exception, definitely not the rule. But it is quite well studied. So why cooperate? The big obvious answer is you can get larger prey than you can get by yourself. And it allows them to exploit a niche that they wouldn't necessarily be able to exploit if they were hunting on their own. But the sort of more detailed answer is there's actually 2 reasons why lions cooperate. On the really big prey, they actually need 2 individuals to subdue and kill the prey. On the smaller prey, it's thought that they need two individuals to capture the prey, but then one individual is actually responsible for killing it. You don't actually need multiple individuals. So in the example with zebras here, you don't actually need that second individual to kill the prey. You just need them to capture it. And as a result, lions have developed pretty sophisticated hunting techniques, and it's thought that they actually take on different roles. So what you see over here is the different setups. So A, B, C, D, E, F, and G are all different lions. And the positions on the end are called wings. And so the wings are the ones that come out the side, circle around, and come in front of the prey. The middle positions are the centers, and the centers drive the prey. So they determine the direction the prey is going to go. They, sort of keep the chase going on, that kind of thing. And what happens is eventually, everybody sort of circles around the prey, and you have the prey completely, basically caught. And female lions actually develop preferred positions. So there are some individuals that tend to be centers and some individuals that tend to be wings. And those are their preferred positions. And when they're in their preferred positions, they're more successful than when they're not. So if there's a situation where females get out of their preferred positions, they're actually much less likely to succeed. So centers are actually less likely to initiate chases than wings, and they're more likely to be the ones that ambush the prey. I don't think this is particularly surprising, as they're the ones that are sort of driving the prey and right there. Wings are more likely to rush the prey and initiate chases, and wings actually travel about 10 times as far over the course of a hunt as a center does, because they're going that far in front of the prey. What's interesting was in the study group, so that data came actually from 4 study groups. In one of those study groups, there were actually 2 females that routinely broke away from the pack and hunted just as a pair. And what was interesting that they found is that, so if you look, these are the same roles that correspond to here. The clear bars are one individual and the shaded ones are the other. They adapt to each other. So when one individual is more to the left, the other individual is more to the right. And this suggests that they're really sort of taking into account the behavior of the other individual. It suggests us a fairly sophisticated level of coordination that's going on here. And really the determining factors seem to be that they kept the prey in between them, and then one would eventually sort of run around, head them off, and capture them. So the level of coordination actually seems fairly high among lions. So now they've caught the prey. The question is, how is food divided? Essentially, female lions have very low dominance. So the statement up here is no dominance. That might be a little bit extreme, but they really don't have very strong dominance hierarchies, meaning there's not somebody who's sort of more entitled to food and somebody else who has to scrounge. And they have equal access to food. So a study actually went through and measured the belly distension in female lions after eating. And they found that essentially all the females had the same amount of distension, meaning essentially they inferred that they all got approximately the same amount of food. So for me, as a person who's really interested in cooperation, this was a pretty big puzzle, because if everybody gets a fair share, why isn't there a cheater? Why aren't you the one that comes in after everybody else catches the prey and gets the food, if you're going to get it anyway? And they do refrain across the board from about 33% of hunts. So there actually is a fair amount of time where someone is coming in and getting food and not actually working for it. But they're refraining a lot more on small prey than on larger prey. So, for example, warthogs, which don't require that many individuals. Not that many individuals are working for it. More individuals are coming to get the food. And overall, more participation equals more success. What I would suggest, and I think that this is relatively unexplored and would be a really interesting future direction, would be that there's probably some sort of repayment. So if you're the one that catches the warthog at this point in time, somebody else should be doing it at a different point in time, and you should be benefiting from them. That would be my guess, is that there's some sort of reciprocity going on. And the same argument can be made for male lions. You've noticed I've said a lot of things about lionesses and female lions. Male lions hunt either solitarily, they rarely hunt in packs, and they often eat food that female lions get from hunting in packs, which would mean, by the sort of broad definition of freeloaders, they are coming in and freeloading. But I would probably argue that they're providing some sort of benefit to the group that is, paying that back in a way. so possibly protection from intruders or something like that. But I think that the mechanism by which cooperation is sustained is really unclear at this point and definitely bears further exploration. So, lions are definitely the exception, but an interesting thing that came about purely by chance is we discovered that they're not the only ones capable of cooperative hunting. And there were 3 cheetah brothers. I'm sure some of you have maybe seen this. It's very popular on nature shows, that were orphaned. And they were old enough that they survived, but not so old enough that their hunting techniques were completely refined. And they actually spontaneously developed cooperative hunting. So the tendency seems to be there, even though they actually, generally as adults, wouldn't be using it. So I have a video of that, and you're actually going to see them go after an ostrich, which is 3 times the size of a cheetah. And you can see what they do and how they switch prey. I will put out a little word of warning for those of you that might be a little more sympathetic to the ostrich. This is a video of hunting, so just bear that in mind. So if any of you have ever seen a video of lions hunting, one of the things you probably noticed is that it's not nearly as coordinated as that, right? But on the other hand, it still says something to the fact that one of them actually switched prey and the others followed along. So it does seem like, although maybe it's not as refined as you would see in lions, they are very, very capable of this type of cooperation. So just to sum up, my argument would be that we see complex cognitive skills related to predatory behavior in cats. And it's a relatively understudied field, and I think that, there's a lot of further exploration that could happen. And I would actually argue that it leads to highly developed sociocognitive skills, even though people will laugh at me when I say social cognition in cats is an interesting topic. I think the specific needs of them as a species really leads to a need for social cognitive skills, especially throughout development. And that these are actually fairly widespread throughout felidae. And some of these things are things that are not widespread throughout virtually any other group of mammals, including primates. So thank you. Thank you very much to Alan Norgress for the funding, Mike for the invitation, and Matt for some feedback. And, of course, my cat.